Lesson 8.2, using distributive property. Now, if you remember the lesson 8.1, we were using GCF to factor things. Well, the only difference between GCF and this problem is this plus sign right here. Now, that plus sign wasn't here, and I said, okay, find the greatest common factor of 27y squared and 18y. You should be able to do that. So I'd like you to take a moment to review 8.1 and go ahead and find the greatest common factor. So go ahead and pause and find the greatest common factor. All right, so 27 is 9 and 3. 9 is 3 and 3. 18, 9 and 2. 9 is 3 and 3. So I have a 3, a 3, a 3, 2 y's, a 2, a 3, a 3, and a y. Now my greatest common factor, 3, 3, and a y, which makes 9y. Now, if there was not that plus sign, which, let's bring it back, that would have been the answer. Instead, we're trying to figure out what two things multiply and give me 27y squared plus 18y. So what we're missing here is two parentheses. Now, my question to you is, what times 9y makes 27y squared? And then, what times 9y makes 18y? And the answer is 3y plus 2. And in case you didn't notice, what I didn't highlight over here was a 3y and a 2. The stuff that's not highlighted from the greatest common factor goes inside the parentheses, and that's how you find the answer. So the greatest common factor is in front of the parentheses. Anything that's not part of the greatest common factor goes in the parentheses. Now, if you perform distributive property and did 9y times 3y, 9y times 2, you get the original problem. So you can check this if you want to. Now here's B. Do the same thing. Break this down, and break the last one down. Write out all the factors all the way across, just like you did before. So pause if you want to do that. So 21 is 3 times 7. 7 is just 7, and there's no number in front of the UT. So 7 U U T T. 3 times 7 U T T. And for the last one, don't forget about that negative 1 U T. Now again, the greatest common factor is what's in all three this time. Normally, greatest common factor is in what's in two of them, but in this case, there's 3 parts, so the greatest common factor is in what's all 3 of them. There's only a 7 in 2 of them, but there is a U in all 3, so I'm going to put a U down. There is a T in all 3, so I'm going to put a T down. And then I'm going to have parentheses and fill in what's not been highlighted. In the red part, that's 7UT. The green part, 3 times 7 is 21T. In the blue part, the only thing that's not highlighted was the minus sign, so I'm going to put minus 1. Now, if you were to perform distributive property and multiply that parentheses times UT, you would get the original problem. So that's how you factor. Put the greatest common factor in the front. Anything that's not part of the greatest common factor goes in the parentheses. Okay, a 4-term one. First thing you want to do is look at all 4 of them. You see the 4, the 8, the 3, and the 6? Is there a number that divides all 4 of them? No. Is there a Q in all 4 of them? Nope. Is there an R in all 4 of them? Nope. So there's nothing in common for all 4 terms. In that case, you should group the 4 terms. Group. So I'm going to put them in groups of 2 with something they have in common. So 4 and 8, they go together. And 3 and 6, they go together. Now I'm going to factor each group separately. So 4 is 2 and 2. 8 is 4 and 2. And then 4 is 2 and 2. So 4 is 2, 2, QR. 8 is 2, 2, 2, and an R. Now I'm looking for what they have in common. And that is 2, 2, and an R. Put that together, that's 4R. What I didn't highlight was a Q and a 2. Q plus 2. Now I'm going to try the other parenthesis. 6 is 2 times 3. 3 is prime, it doesn't break down. So I got 3 and a Q, that's all there is. 6 is a 2 and a 3. It's okay that there's only 2 terms for each part. They still have something in common. The 3's. So put that 3 on the outside. And then what didn't go together goes on the inside of the parentheses. The Q plus 2. At this point, you should notice that the 2 parentheses are the same. Now, according to distributive property, since the 2 parentheses are the same, you only need to write that parenthesis down once, and then put another parenthesis in front of it, and put the 2 greatest common factor parts in that parenthesis. The 4R, and since 3 is positive, plus 3. Since distributive property says 4 will be multiplied by the parenthesis, 4R times both parts, and then 3 times both parts. So distributive property still says that both parts are going to times that parenthesis. So that's the answer. You put the first GCF, then the second GCF, and then the common parenthesis in the back. All right, let's try another one. Go ahead and see if there's something that goes into all 4, and if not, put them in groups of 2. If you'd like to try this on your own, you should pause. Okay, so you should have put the first 2 together again with, that's not highlighting, with the second 2. Now, you could have done it differently, but this is the most common method, is using the first 2 with the last 2. 15 is 3 and 5. 3, of course, is just 3. So 3 NP, 3 and a 5, and then a P for the first 2 terms. Greatest common factor. The 3's and the P. So I'm going to put 3P in a parenthesis. And follow that up with n plus 5. Over here with this one, 4 is 2 times 2. 20 is 4 times 5, and then 4 is 2 times 2. And then don't forget that there's a negative in front of each. So I want to write this out. That's going to be negative 1, 2, 2, n. Negative 1, 2, 2, 5. Now hopefully you notice that your greatest common factor includes a 1, 2, and a 2. So this is why it's important to keep that negative 1 as a separate part. So if you times negative 1 times 2 times 2, that's negative 4. And then what's not highlighted is the n plus 5. Now again, you notice the parentheses are the same. So put the parentheses, put one of them down, n plus 5, and then put in the parentheses in front of that, first the 3p, and second the minus 4, the two GCFs. And that's how you factor p. All right, we'll try another one. Again, see if there's anything that goes into all four. If there's not, start looking to see which two you would like to group together. All right, so if you group the first two again, at least they have a C in common. That's one thing. And if you're going to put the second two together, 4 looks like it goes into both numbers there. So all I have is a C for the first part. I have a minus 1, because there's a minus there. A 2, a C, and a D. The only thing they have in common is the C. Let's be consistent. Put that back yellow. So I'm going to put my C in the front. And then since there's nothing left on the top, I have to put something there. And what could be times C that keeps it the same? A 1. So I'm going to have to put a 1 in front. And then minus 2D. Now for the second part, 8 is 4 and 2. 4 is 2 and 2. 4 again is 2 and 2. So I've got 2, 2, 2, D, a negative 1 because you see that little negative sign right there. Negative 1, 2, 2. Look for what they have in common. 2, 2. So I'm going to put a 4 in the front. And then parentheses. 2D minus 1. Now, if you notice, the parentheses are not exactly the same. This one starts with a 1, while this one ends with a 1. This one has a minus 2D, while the other one has the minus with the 1. So something's a little off there. Now, if I want the 1 to be positive in the second one and the D to be the minus part, I have to multiply them by negative 1. So if I was to multiply by negative 1, it would change the sign. Now, multiplying by negative 1 on its own would change the problem. But if I multiply the front by negative 1 and the back, the two negative 1s would actually cancel each other out. So I'm going to multiply the front by negative 1 and make it a negative 4. Now if I multiply the inside by negative 1, that's going to turn the 1 into the positive and the 2 into the minus. So I'm going to go ahead and reverse them. Now it matches up. So since my two parentheses are the same, I'm going to put my GCFs in the front, C minus 4, and my common parenthesis in the back, 1 minus D. And I got one more just like this for you to try to do. Okay, so group these together. So what do we have in common in the first part? Looks like we have a P in common, because 3 and 2 are totally different numbers, and the only thing they have together is P. Now, if you don't want to write all that work out on the last one, it's like, well, if you know the greatest common factor is P, well, take out the P. If you were to take a P out of 3P, you'd be dividing by it and crossing it out and leaving you with a 3. If you were to divide by P in the second part, you would subtract exponents. 2 minus 1 is still 1, so you'd have minus 2P. So if you know the greatest common factor, you could just divide by it. If you don't know the greatest common factor, write out all the factors, just like we were doing before. Like in the second part, 18. You may not know that the greatest common factor between negative 18p and 27 is 9. So you might have to work it out. 2 times 9 is 18. 3 times 3. 9 is 3 times 9 times 3 makes 27. 3 and a 3. Negative 1, a 2, a couple of 3s and a p. 3, 3, 3. So if you work it out, you'll see your 3 3s. You see you get 2 sets of 3s. So that makes 9. And then negative 2p plus 3. Now hopefully you notice that these parentheses are backwards again. So change the 9 to a negative 9. Change the p to positive. Wait a minute. No, these are the same, but they're just reversed, right? So don't forget that you have commutative property, and you can reverse them. So if they're opposites, change the sign of the second one. If they have the same sign but they're backwards, just remember that all you have to do is flip it around. Now that the parentheses match up, go ahead and put that first GCF, 9 and P, in the first parenthesis, followed by 3 minus 2P. And that's how you factor using distributive property.